Hi, welcome to Unit 3. This is Ms. Clemens-Brenton, and in this unit we'll be looking at operations with fractions. In previous grades, you learned to add and subtract positive fractions and mixed numbers with like and unlike denominators. In this unit, you will extend your knowledge to explore multiplication and division of fractions. We will begin by modeling fraction multiplication with pictures using fraction circles and number lines to generalize a rule for multiplying fractions. We will then explore division in a similar manner, beginning with modeling and then moving to the symbolic level to eventually combining all four operations with fractions and applying the order of operations. In this video, we'll use models to multiply fractions and whole numbers, specifically fraction strips and fraction circles. So let's get started. In Unit 2, we saw how multiplication is really just repeated addition. For example, -3 plus -3 plus -3 plus -3 is really just 4 times -3 because we have 4 groups of -3. Fractions can be written in the same way. For example, 1/5 plus 1/5 plus 1/5, because there's 3 groups of 1/5, we can write 3 times 1/5. So remember, multiplication means of. Anytime you see 3 times something, that means 3 groups of something. So to model multiplication of fractions, we create groups of the fractions. So we can use fraction strips to model that example. So 3 times 1/5 means we need 3 of 1/5. So we can draw a fraction strip cut into 5 pieces, and to represent 1/5, we would shade 1 piece out of the 5. We need 3 1/5s, so I'm going to draw this 2 more times. And now I have 3 1/5s. When combined, I can move those 3 shaded pieces all into the same fraction strip. So I redraw the fraction strip cut into 5 pieces, and then I move those 3 pieces to that fraction strip, and we can see that we get 3/5. So 3 times 1/5 is equal to 3/5. So here's another example, 4 times 3/5, and I can use fraction circles to model this one. So if I need 4 times 3/5, that means 4 of 3/5. So we can draw a circle that's cut into 5 pieces, and to show 3/5, I would shade 3 of the 5 pieces. So that's 3/5. Now I need 4 of those, 4 groups of 3/5. So I draw 3 more circles with 3/5. So when combined, I'll redraw my fraction circles, and I'll move all the shaded pieces to make full circles. So when I move the pieces over, this is what I get. So I can see that I have 5 shaded pieces in the first circle, 5 in the second, and 2 in the last one. So in total I have 12 pieces, and my denominator is 5, so that's how many pieces each circle is cut into. So I have 12 pieces out of a total of 5 in each circle, so 12 out of 5. So 4 times 3/5 is 12 over 5, and I can write that as a mixed number by counting up how many full circles I have, which is 2, and then there's 2 pieces left over out of the 5. So 12 over 5 is also equal to 2 and 2/5. Example 1. Use fraction circles or fraction strips to show each product. So 3 times 3/7. I need 3 groups of 3/7. So to draw 3/7, I'm going to draw a circle split into 7 pieces, and I shade 3 out of the 7, and I need 3 of those. So I draw 3 sets of that. Then I tally up how many pieces I have together. So I have 3 in the first one, 3 in the second one, and 3 in the third one. So in total, there are 9 pieces out of 7 possible pieces in one fraction circle. So I get 9 over 7. If I combine all those pieces into one fraction circle, you can see then I have 1 full circle and 2 left over in the second one. So 9 over 7 is equivalent to 1 and 2/7. The second example, 1/2 times 8, that means I need 1/2 of 8. So there are a couple different ways that this could be represented, but in this case I drew 8 circles and I took half of each one. So in total now I have 8 pieces, over 2 possible pieces in each circle. So that's 8 over 2. If I combine all the pieces and put them all together, you can easily see that we end up with 4. So 8 over 2 is equivalent to 4. So 1/2 of 8 is 8 over 2, or 4. Please proceed to the next video in this lesson.